Hello everyone. So this was my first video. So I would like to actually teach digital electronics related subjects like IC designing, Verilog programming, behavioral programming, and VLSA related subjects. So let me introduce myself. Myself Dhanlakshmi. So I would like to start with the basic subject, that is the digital electronics, which is a very basic for this all the digital related subjects. So if you are interested in the VLSA side, jobs or anything, so the first basic thing it starts with the digital electronics only. So I would also love to start with the digital electronics subject as well. So today I'm going to give a basic, the first whichever subject you go, we will start obviously from the basic. So here it goes with the first topic, the number system. So since our childhood, we are habituated with this decimal number system, which is a radix 10. We call it as a radix or else a base. Okay, so decimal number system, which is a very well known for everyone. So when it comes to the digital electronics or digital systems, so here comes the other three binary, octal, and hexadecimal number systems. So they differ in the radixes, that's it, and the range of values it is ranging from. So the decimal number system, as we all know, the base on radix is 10, binary number system the radix is 2, and the octal number system is 8, and hexadecimal number system is it is 16. So whenever we go to the computer language, obviously it will be in terms of a binary number system. So here comes the next octal number system and hexadecimal number system. So this is all the two power numbers. So 2 power 1, 2 power 3, and 2 power 4, like that. So this is all the machine language related number systems. But ours is a decimal number system which is understandable by the humans. Okay, so it is important to know the conversions from decimal number system to the other number systems and other number systems to the decimal number system as well, right? So before that, let us first know how we are going to represent the numbers in each different number systems. So here comes a table. We can see here the decimal, binary, octal, and hexadecimal numbers. So these are all the values that we come across here. So this is the basic one, which would be great if you remember all these values. As you know, the decimal number system, it is already well known to you. So the one thing you need to remember here is the decimal and hexadecimal, binary, and octal. Okay, so decimal number system, obviously we know it ranges from 0 to 9. So this is all decimal number systems. So as it is a radix 10, it will have a 10 numbers. And the binary, we have two radix, that is nothing but it is having only two combinations, either 0 or 1. And when it comes to the octal, it is totally 8 combinations. So it is ranging from 0 to 7. So after 7, there is no 8 here. So 7 is the maximum digit in the octal number system. So when it reaches the maximum number, obviously the next will be this one. Okay, so here also in decimal number system, when it reaches the maximum digit in the position, it will go next is 0 and the next bit will be incremented by 1. So likewise in the octal number system as well, when it reaches the maximum digit which is a 7, its next number is 1 0. We should not call it as a 10. It is called 1 0, right? And in hexadecimal number, totally it is having a 16 combinations because it is a 16 base, right? So the first 10 numbers is 0 to 9, and the next 6 we represent it with the alphabeticals. So that is A, B, C, D, E, and F. Okay, so here A is equivalent to 10 in decimal number system, and B is equivalent to 11 in decimal number system, and likewise. And here the last digit in hexadecimal number is F, which is equivalent to 15 in decimal number system. And here in binary also, we can see here this is a 2 representation in binary, 3 representation in binary, 5, 7 and 15 we can represent it with 4 ones. So this is how we represent it in the binary number system. Okay, so this is all about the numbers and their representations in general. So we, it is important to remember from 0 to 16 or 0 to 15, whatever, all the 16 combinations, right? So if you are facing any difficulty in representing a binary number system, I have a idea to remember here for the binary, because hexadecimal and all you can do well if you know the binary number system first. So the first binary number, for example, if I want to write a binary number for 34, so consider this is a base 10. Now I want to represent this in the binary number system. So the simplest technique first is you can write 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. So why I'm writing here is each and every digit is having its own positional value. For example, if you write a decimal number like this, we will call this as units place. And this is tens place. And this is hundreds place. Whichever is representing 10 power 0, 10 power 1 and 10 power 2. So all the positions is having its place value. It is very important to have that place value. So likewise in binary number system also, if you are representing here, here also it is having a positional importance. So here 2 power 0 means 1, 2, 4, 8, 16 and 32. So now here I want to represent 34 decimal number in binary number system. So here starts with 34. So 34 here, whichever it is matching the maximum, first we need to fill it 1. So that is 32. And after 32, what is the remaining? If you subtract 34 minus 32, the balance is 2. So here 2 is there. And we can fill the remaining positions with zeros. So we can finally write the 34 in decimal number system is equivalent to this in binary number system, that is 1000110. Okay, so this is how we can write the binary numbers if you know this conversion. So this will be easy to remember if you are facing any issue at the starting. So here also the same value, like you can have 8421, you can remember simply. Okay, so if you are representing for example 10, so here you see 8421. So 10 you need to represent it with 8 plus 2. Then fill it with zeros. That's it. Okay. So 8 plus 2, it is giving 10. So for example, if you want to go to 13. So 13 you can represent first the maximum value is 8 and remaining is 5. So 5 is a combination of 4 and 1. So here comes 1101. So this is the simplest technique to remember initially. So once you get habituated, obviously you will remember all these values. There is no doubt. So initial stages only, this is very important for understanding or writing a simple binary number representations in terms of decimal or hexadecimal. Okay. So I hope this is clear, the table. So you need to remember from 0 to 15. That's it for binary and hexadecimal. So most of the cases we won't use octal because this is only confined to the number system conversions and all. So when you are going on with this flow, octal number system we were nowhere using, only for the number systems and all conversions types only we are using this octal number system. And as the subject goes on, octal is nowhere used. Okay, so the main thing you need to concentrate on decimal, binary and hexadecimal, right? I hope this is clear, and we can go to the a simple number conversion systems. So the first one is, number system. You want to go to convert it to the other number systems. So this is one key. This is a question. So don't worry, it's not. So this is after and this is exercise. So I want to convert it to all these three number systems. So I'm taking a decimal number system 192 and converting it to the other number systems, that is binary, octal, and hexadecimal. So the first basic rule here is, if you are converting it from the decimal number system to other number system, directly take the number 192 and divide it with, continuously divide it with whichever radix you are converting. For example, if you are going to convert it to base 2, okay, so the first example I'm taking is 192 decimal number. I'm going to convert it to base 2. Okay, so what will be the 2? It will be 96 base 0. And the next is again divide it with 2. Then you will get 48 base 0. Sorry, remainder 0. 2 divide again 24, remainder 0. Next 2, 12, remainder 0. Next 6 and remainder 0. Next 3 and remainder 0. Next 1 and remainder also 1. So after this continuous division with the radix number, now you need to start it from the bottom and you need to go towards top. Now you can write one, double one, double double two, double zero. So this is how you will decimal numbers with the binary number system. But what you want to do is to remember which number system you are converting. So that is more important here. Okay. So this is the conversion for decimal number system, binary number system. So likewise, conversions as well. So decimal number system to octal number system and hexadecimal number system as well. So I would like to go on with the next one. Okay. I think there is no undo here. Mm, okay. So let's erase everything. The next example. Now I am going to the octal number system. So decimal number system to octal number system. So here also the same concept. You need to take the number, whichever number we are having, 192, and divide it with the this radix number 8. So when it is 22 divided by 8, here comes 24 and remainder 0. Again divide the 24 with 8, 3, 0. Okay, so start with the bottom always and go towards top. And now the final answer will be 300. So this is the octal representation of 192 decimal number. Okay, so likewise only we can convert the same decimal number to hexadecimal number. The only change we will do here is the division value. So take 190 and divide it with 16. Okay, and reminder. Now we can forget this, right? Now the concept is not like 12 here. This is not 12. So I have already shown you this one. So decimal 12 is equivalent to C in hexadecimal, right? So this is very important to remember till 15. Okay? So the 12 decimal is equivalent to C in hexadecimal. So the number 0 base convert a decimal number system to the other number systems. So finally, I will write one more time the answers here. Now, I would have double one, double zero, double zero. So this is binary conversion. And when it comes to the octal conversion, I got 300 octal. And in hexadecimal, it is C0 hexadecimal. So in the number systems, it is very important to represent the base. Every time, don't forget to represent the base. Without representing the base number, the number itself is a no meaning. So even if you are writing a decimal number system which is already known to everyone, then also you need to represent this radix, which I mean this one. So if it is a decimal number, you need to represent it with a 10. This is a binary number, octal number with base 8, hexadecimal number with base 16. So this is a conversion from decimal number system to other number systems. Now let's go to the next type of conversion, that is other number systems to decimal number. So this is the same kind but a different method. Okay. So now let us take a different number system and we can convert it to the decimal number. Now one, this is a binary number. I wish to convert it to the decimal number. Okay. So previously what I have said is the conversion of decimal number system to binary or octal or hexadecimal. What we have done there? Division, right? Division with the radix. Here, the reverse process. Reverse conversion, right? So we need to do multiplication. There we are doing the division process. Here we are doing the multiplication process. First take this number. So whatever number is given there. So now here comes the positional values. Positional value. Okay. Each and every position is having some value, right? If a person is sitting higher authority, based on where they are sitting, there is some value, right? If you are sitting on the floor, it is different. And if you are sitting on a chair, it is different. And if you are sitting on a crown, the value is different. Okay. So the based on the place where you are sitting, the value will automatically change. So here the 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. So after assigning all these values to each and every position, now we need to go with the multiplication process. So the multiplication is very easy, I hope. Okay, let's go with that. So here 1 into 2 power 0, that is 1. Next 0 into 2 power 1, that is 0. And next 1 into 2 power 3, sorry, 2 power 2, that is 4. Next 1 into 2 power 3, it is 8. Okay. Next 0 into 2 power 4, that is 0. And 1 into 2 power 5, that is 32. So finally, you should add all these numbers. So you can add 1 plus 4 plus 8 plus 32. Finally, the value will be 45 base 10. Okay. I hope this is clear. Okay. Right. So this is how we are going to convert a binary number to the decimal number system. So likewise, we can convert from octal to the decimal number system, hexadecimal to the decimal number system as well. So this is one example, and let's go with the other two examples also. So now I am 634 base 8 to decimal number system. Okay, right. So same, take the value 634, assign the positional values 8 power 0, 8 power 1 and 8 power 2, and then 4 into 8 power 0, 3 into 8 power 1, 6 into 8 power 2. Okay, so this is 4, this is 24, is 384. Okay, totally if you add 384 plus 24 plus 4, it is 412. So this is base 10, that is decimal number. So here 634 octal number, if you convert it to decimal number, that comes the 412 decimal number. Okay, so this is how we are converting the octal number to the decimal number system. And the next example is F3A hexadecimal number to decimal number system. Okay, so here also taking the same F3A 16 power 0, 16 power 1, 16 power 2. Okay, so here A means in decimal it is 10. Okay, 3 into 16 power 1, and F is nothing but 15 into 16 power 2. So you can first multiply all these values and then we can go for the addition. So 48 16 square into 15 you need to do, that is 3840. So finally we can add all these things. 3840 plus 48 plus 16. So finally 3904. This is the decimal number system. Okay. So here this is process for converting other number system to the decimal number system. Okay, I hope this is clear. So when we are going for the conversion from decimal number system to the other number systems, we go with the division with the radix number. Okay, and in the inverse process, when you are converting from other number system to the decimal number system, we will go with the multiplication with this positional values. Okay, so if you remember this process, then obviously it will be easy for you to convert from any number system to any other number systems. Okay, and till now I'm concluding here for the first video, and in the next video we will learn about the normal floating numbers. For example, here till now we have gone with the only integer numbers, but when it comes to the floating point numbers, the conversion is a little bit different. Integer part it is okay, the floating part there will be a difference. Okay, so that we can continue in the second video. Okay, I hope you enjoyed this video. Thank you so much, and we will continue in the second video then. Okay, thank you.